Fine. Now, as advised by Mr. Kharbanda, we are going ahead with the speakers. I'm trying to see if our friends from Patterson and Cook, they have joined or not. I'm just again asking you, there's a person called Mr. Julian Rasconi. Is he there? And Mr. Stephen Young.
Both of them aren't there as of now.
They are not there. So let us start with the lecture or the first session of Julie Harris and Raj Talamudupula. Is it all right? Are you both here? Julie?
Yes, we're here.
Yes, yep, we are here.
Yeah, both are here. So it gives me great pleasure to introduce both Julie and Rajendra. Now, I'm so delighted that Julie, being a lady, she has so many years of experience in pipelines. Particularly, Julie, I'm delighted that you have experience in India. You have designed
Absolutely, sir.
ArcelorMittal Nippon Steel Paradeep pipeline, Dabuna, and you have first-hand experience of working in India. And you are such a thoughtful lady, Julie. I see the map of India behind you. That's good. That's very, very thoughtful of you to keep India in the focus. And Julie has around 14 years of experience in pipeline, process, and mechanical design engineering from conceptual study level. Her experience also includes long-distance slurry pipelines. Important thing is tailing pipelines. I'm still wondering how will it happen? And probably you can touch upon that. Distribution systems. And Julie focuses on coordinating the engineering of large slurry pipelines projects, especially in India. And the best part, I'm delighted, she also mentors young engineers on pipeline. Thank you.
Absolutely.
Over to you, Julie. May I say a few words about your colleague, Rajendra? If he is there, he can show his face. And Rajendra has over he's Rajendra Talamudupula. I'm sorry if I'm not able to pronounce your name. They are both in California right now. Luckily, California is around 10 p.m., not too late. Rajendra has over 16 years of professional experience. The fantastic thing, I never knew this, that the largest concentrate pipeline system of 38 million ton per annum is in Morocco, of all the countries.
Yes.
I never knew Morocco is on the world map of pipelines. So thank you very much. And he is a top person from a company called Osenco, which are developing the largest iron ore pipeline project, especially in India, with capacities up to 30 million ton per annum. And I'm glad that Raj is here with us, and we will see more of Raj and Julie in the coming years when there are a lot of pipeline projects lined up in India, I hear. So over to you. I think Julie will be presenting.
There will be a joint presentation. We'll be doing half and half, approximately.
Please. So the floor is yours. No hurry. One thing I wanted to repeat to both of you that we are recording this, and I hope you don't mind it.
Absolutely fine.
If there is any confidential data, you can either hide it or tell us.
Sure.
Sure.
Okay.
And
No
again,
problem with that.
My colleague Vijay is here. I just want him to show his face. He's Vijay Dwivedi. He is. Hi everybody. He's helping me.
Good morning, sir.
And in future, as I get older and older, he'll be the guy to respond to you on emails. So he's there. He has a long service record of Ministry of Environment. In fact, he would be more than aware of this 300 million tons of dumps because he was directly working with the Environment Minister at that time. His name is Mr. Javadekar. Of course, now he's not there in that position. So over to you, Julie. Yeah.
Can you enable me to share my screen, please? I have a presentation.
Rishabh, kindly share the screen. Julie wants to share.
Is this Julie? You can share the screen. You have the access.
All right. Please tell me when you can see my screen.
Oh, wow.
Yep.
Good.
We can see Julie.
Yeah, we can see it.
All right. Thank you for the kind introduction, sir.
Okay. I'd really like to thank PMAI and Mr. Deepak for, coming to us and asking us to participate. And we would really like to be part of the solution in making this dream of achieving 300 million tons of, steel capacity happen in India. We really believe there's a huge potential, and we want Ausenco to be cooperative and make it a grand success. Next slide, Julie. So maybe for people who are not aware of Ausenco and what we do, so there are currently 3 operating iron ore long distance pipelines in India, 2 by SR, now obviously by AMNS since they've taken over, and 1 by BRPL. So all the 3 operating pipelines were designed by Ausenco. Then there are 2 pipelines currently under construction. One is the NMDC Bacheli to Nagarnar pipeline, and JSPL's Barbil to Angul pipeline. Both have been done by Ausenco as well. And as you can see, there are several upcoming pipelines. So engineering of all those pipelines are being done by Ausenco. And I'm really proud to say that there's no Slurry pipeline project without involvement of Ausenco. We are the pioneers in technology. And, me being an Indian, I'm from Hyderabad, I'm really happy to be a part of, the goal of achieving 30 million tons. See, since we are dealing with all the clients in India, we have a really holistic view of what's going on in the industry as well. So I thought, based on all the conversations we're having with all these clients about long distance pipelines, and the fact that, the grades are becoming lower and lower, which means they need to be beneficiated, which means they are tailor-made for long distance pipelines. And, the particle size distribution of the pipelines with pellet, it's a match made in heaven. So I think long distance Slurry pipelines are the way to go forward. So we thought, we should address a few things to make this dream of achieving 300 million tons a success. Next slide, Julie. So, okay, we talk about 300 million tons. I've been hearing that for many, many years now. But what does it practically mean? Okay, I mean, it's great to talk about it. So what are we talking about? So to make a ton of steel, we need about 1.6 to 1.7 tons of iron ore. So we're talking about transporting 500 million tons of iron ore to the steel making facilities. Which means if you look at about 15 million tons of capacity per year, we're talking about 33 Slurry pipelines to be commissioned between now and 2030, which is about 4 a year, which is very, very ambitious to say the least. And obviously, Slurry pipelines need a lot of water. So we calculated that we need about 45,000 cubic meters of water an hour, which is about 4 cubic, to transport all this slurry to the iron and steel making industries. And either it is fortunate or unfortunate, but obviously Odisha is the heart of the iron mining operation in India. Majority of the pipelines that we deal with are being planned in Odisha, especially in the zone between Barbil, Dabuna area, and the coast of Odisha, either it be Paradeep or Dhambara or any other area. So that's where most of the action is with respect to Slurry pipelines and the iron ore industry. So for me, if we cannot answer these 3 questions, then, the dream of 30 million tons will become difficult, if not impossible. So the 3 questions that I have, or we face all the time is, where is the space for these 30 plus pipelines, right? I mean, and the second question is, where is the water going to come from all these pipelines? And what about the safety and security of all these pipelines? So we think these 3 are the biggest challenges in achieving the goal of 30 million tons. And we would like to address that a bit detail going forward. Next slide.
All right. So slurry pipelines are now primarily being planned in the national highway right-of-ways, which facilitates the permitting with a single agency. However, many of these projected 30-some pipelines would be concentrated in the same area, as Raj mentioned, and only the first few are going to find space in the national highway right-of-way, actually. Additional areas are going to need to be developed, such as the right-of-ways of secondary roads, railway lines, potentially even the development of some wide common corridor cross-country should be considered, that multiple pipelines could be installed in parallel.
Mr. Dwivedi, you need to keep it on mute, please, so that.
So one solution to this lack of space is common carrier pipelines, in which multiple companies would transport their product in the same pipeline instead of in several smaller pipelines. And that saves a lot of space in the right-of-way, as we can see with these images. All of these images of trenches are for 30 million tons of ore. We can carry it in one large pipeline or a bunch of small pipelines. Common carriers take good advantage of the available space that we have. So another pipeline system that's actually operating that sort of uses this philosophy is a phosphate slurry pipeline network in Morocco that you, sir, mentioned earlier. This phosphate slurry pipeline network is a common carrier for 4 different product grades of phosphate. There are 4 plants producing materials and 4 short pipelines bringing things to a central location, and then a 180-kilometer long distance pipeline that transports the material from the interior of the country to the coast. And even this end material is feeding end users with 15 discrete acid plants owned by different companies. So this is a concept that's been applied in other places and may enable the industry to use larger and fewer pipelines. So the benefit of common carrier pipelines is that you can use larger diameter pipelines, and the larger diameter pipelines have lower friction losses than smaller pipelines. That results in lower cost per ton of ore transported in terms of both capital cost and operating cost. If we look at the numbers here, these estimated numbers for different size pipelines, to triple the capacity of a pipeline, to use a larger single pipeline, only requires about double the cost infrastructure. So there's really a financial advantage to going to larger common pipelines. Additionally, you can see the comparison to rail and trucking. The operating cost of slurry pipelines is drastically lower. It's so low, in fact, that the return on investment for the capital cost of slurry pipelines is only a few years in comparison to the cost of the tariffs for transporting material by rail or trucking. So to find the space that's needed to install all of these pipelines, we have to look at more space to be made available, in particular in right-of-ways and secondary roads, thinking of developing common cross-country right-of-ways, railway right-of-ways, and also to make the best use of the limited space available by looking at common carrier pipelines, which would be a new concept for slurry pipelines in India, but we think it's something that's possible. So the next issue that we want to address is the water scarcity in the future. So since these iron ore deposits are concentrated in the same area, that means the pipelines are concentrated in the same area, and the water that needs to be drawn from rivers is going to be concentrated in the same area. It's going to be drawn from the same rivers. For this 50 million tons of iron ore that we need to transport, we need 450 cubic of water to transport the iron ore in a slurry. As climate change continues and as more pipelines are built, water may not be sufficiently available for all these pipelines, especially seasonally. If water is not available for the pipeline transport, that stops the transport of the ore. So we want to think about alternative sources of water to provide stability and security for slurry pipeline operations. So options for that are return water pipelines, which reuse the filtrate removed from the slurry at the end of a pipeline and returns the water back to the pump station to use a sort of closed circuit system. So we're not losing so much of our water. we can recover a very significant amount of the water and reuse it in a closed loop. Another important solution to think about is an alternative source of water, which would be desalinated water. Many other countries are using desalinated water for their mining needs. In particular, Chile, Peru, Australia, and also again to the phosphate pipelines in Morocco. They are currently developing desalinated water pipelines. You can see in the plot here on the side, about 15 years ago, we started to see a significant increase in the development of long distance, high pressure water pipelines that are required to transport water from the coast into interior areas where mining needs are. So it looks like India may be maybe about 10 years behind the rest of the world, but we think we're going to see a lot of high pressure water pipelines in development, including from desalinated water sources. We think that'll be a good solution to ensure that the pipelines can get the water that they need to operate. You're mute.
Yep, sorry. Okay. So so we made space for constructing the pipelines. We made sure that the pipelines have enough water to operate. But what really keeps me at night is what you're seeing on the screen. In fact, the picture to the left is a leak of the Menacing pipeline, the current largest pipeline for 25 million tons. They actually had 2 leaks back to back. And the government imposed a fine of about 40 million USD, which is about 300 crore rupees. And the operational loss because of lack of production is about 2,000 to 3,000 crore rupees. The picture to the right, maybe most of you have seen it as well, is the Samarco Dam Failure. They had a settlement of about $20 billion, 15,000 crore rupees, and God knows how much money they've lost because of operational shutdown. I mean, we are planning all these pipelines next to highways and railways. Imagine, and these are all high pressure pipelines. We're talking about 30 million ton pipelines. Imagine if this leak happens in the middle of the night next to a highway, and then causes some kind of an accident. It will not only shut down that pipeline, it will shut down all the pipelines in the area. And if the steel industry and the pellet industry are going to depend on pipelines, the whole industry may come to a halt. And in Brazil, because of these 2 incidences, we see a great opposition from the public from putting up new slurry pipelines and for tailings impoundments. Even the government regulations have made it much more difficult to have new projects in Brazil. So for us, this is an issue which needs to be addressed really quickly and should be given a good thought, because unfortunately, the mining industry still treats long distance pipelines as a tailings pipeline. I mean, I've seen conversations equating long distance slurry pipelines to a water pipeline or an oil and gas pipelines. One thing people forget is slurry pipelines carry solids, and solids abrade the pipeline and can cause leaks. So they're very different and need to have a very different operating practices and maintenance practices compared to an oil and gas pipeline or a water pipeline. So we strongly recommend that each slurry pipeline coming up have leak detection, leak intrusion, pipeline condition monitoring, risk analysis, risk mapping, a really good training program, a really good emergency response plan, and a really high-level pipeline integrity program so that everybody knows what their condition of the pipeline is. Because a failure of one pipeline is not only going to affect that pipeline, but all the pipelines. So we strongly believe and recommend that this should be a policy. I feel like the government should actually insist that all slurry pipelines be audited on a regular basis. It may, what I'm saying may not be, it may be a bit difficult to implement, but I think for the long-term benefit of the industry, for the long-term success of the industry, I think it should come from the government. I think they should have standards for the operation of a slurry pipeline. In fact, right now, the construction of the pipelines follow API codes and ASME codes. But I think for Indian conditions, we need codes and standards and operational practices tailor-made to Indian pipelines. So, as Osenco, we are really happy and willing to actually contribute to that. But I feel like, for me, this is one of the biggest risks, which is still not addressed properly because there are so many pipelines planned so close to each other that this actually keeps me at night. And it is my biggest worry that I should not wake up one day and read about it, as Mr. Deepak said, on Times of India on headlines saying, hey, this had a big pipeline leak caused this accident. So there's one area where industry and government should have a really big focus. And with that, I just want to summarize that for me, the three big items are, first, the space for the 30 pipeline should be a common carrier pipeline, and more space should be made available by allowing pipelines in rail right away, or even a specific cross-country right away, especially in Odisha, with so many projects coming up, because there is simply not enough space to put all these pipelines being planned right now with available space. Water is an extremely important issue because of global warming and the lack of availability. Definitely a rainwater pipeline or a big desalinated water pipeline from Paradeep to the Barbil area. In fact, that pipeline could be a 2-meter diameter pipeline, and that water could be shared by multiple iron and steel making industries. So if there is a spirit of cooperation, the water problem can easily be solved. And the third and one of the most important items is there should be standards to make sure that the pipelines operate safely and securely, so that it doesn't affect the entire industry. So, well, our motto is pipeline dreams do come true, and Ausenco is there to help you make your dream come true to achieving this goal of 300 million tons of steel by 2030. Thank you very much.
Thank you very much, Raj and Julie. What we were planning that we'll have questions after we're done with slurries. Is it all right?
Yeah, totally fine with
Thank
Deepak.
you very much. And Raj, you really raised a hornet's nest, as so as to say, that you have told us what are the precautions the government of India should take. And I very strongly request you, sir, that apart from your presentation, you could send us a short note on what the government needs to be very careful about, because I've heard about that Wale thing. And I'm glad to inform you that among our 207 participants today, there is a guy from Wale also with us. So he would be listening to what Raj said, the warning. And my request to Raj and Julie, because you are interacting.